Okay, welcome to this lecture on Python for machine learning models. A very good afternoon to all of you. So, the title of that lecture is Python for machine/deep learning models. So, we will be covering basically a basic idea about the Python and how and why these machine learning or deep learning models are preferred for Python programming language. So that we will be covering. The brief outline of the lecture session is I will be telling you about the brief about the machine learning and deep learning models, why Python can be used for these models, and what are the features for Python for machine learning and deep learning methods. There are certain libraries we will be discussing upon those libraries also, and working environment of Python for machine learning and deep learning. How you can use there are different basically models, there are different IDEs or the environments are there which allows you to write your code in Python programming language for these machine learning methods. There are certain example and use cases that I will be discussing. First is the linear regression. Let us take one example, that is a wheat crop yield estimation. Similarly, splitting of the data to train and test. So these two case studies will be taking with the Python programming language. So if we talk about the machine learning and the deep learning models, so what we say basically machine learning, we can say it is a set of algorithms that parses the data. It goes through all those data sets, learn from the data and apply what they have learned to make intelligent decisions. So basically, it is we can say these models. What they are doing, they are learning from the data in order to make some intelligent decision. Similarly, if we talk about the deep learning models, it is also gaining much popularity due to its supremacy in terms of accuracy when trained with a huge amount of data sets. So if the volume of the data set is very high, in those cases, basically we are using deep learning models. So if you can see over here, the historical data set we have, and then we do the training process is done. Once the training process is done, from that a model is created, and these models are also tested for their accuracy. And then we give the new data to it, and then results are obtained. So this is a very basic workflow of a machine learning method or a deep learning method. Now you have the training data sets, you create the models, you test it, feed new data to it, and get the result. So this is the basic of this deep learning and machine learning model. So basically Python, why we choose Python for machine learning or the deep learning methods? The very obvious answer is it is free and open source in nature. The It is a community friendly and it guarantees improvement in long run as well. So there is a huge amount of communities available. Online communities are there which are continuously providing support for these Python programming languages. Any query you have, you can just Google it and you will get answers to those queries in the form of code and in sometimes in the form of some guidelines also. So a very extensive or a huge community is available there, which is always ready to help you in learning this Python for machine learning or any, it can be for any models we can say. Similarly, apart from being free and open source, it is also have a very exhaustive library. Literally, it is have solutions for every existing problem. So a huge amount of library are there. So you need not to write the code from the scratch. You just need to import those libraries in your code and just call the methods which are available in those libraries. So these are key terms. You can take it from here. Key exhaustive library it is there. Similarly, mm, we have also a smooth implementation and integration process. Very easily you can learn a Python program and you can with a different varying skill levels, you can adapt it very easily. So if we talk about the further, we can say it allows increased productivity by reducing the time to code and debug. You can just see one example I have given over here. Suppose you want to execute a linear regression model on a set of data. So directly one math, you need not to write the full code for linear regression. Simply my model dot linear regression, and your code, by simple one line of code, you are able to get the entire regression equation into your data sets. So thus it helps us in reducing the time to code and debug also. It can be used for soft computing, natural language processing, and some other applications as well. Apart from that, it also have a very good handshake with other programming languages. Like it can work seamlessly with the code which is available in C or C++. It can be have we can also have the codes in written in R programming language or a Java programming language. So they all allows us a very smooth handshake with different programming language. The code written over there, you can integrate them within a Python code. So these are some of the very basic features of Python with respect to machine learning and deep learning. It has a very, you should remember it that a Python has a very simple and easy learning curve. So you need not to spend a lot of time in learning a Python programming language. Within around, we can say, within 15 days or 20 days, you can easily get adapted with the features of Python. You can write some advanced programs also from through your Python programming languages. Basically, it is also a general purpose programming language. It can be used for not only for machine learning, but for some other applications also. The same language can be used. So we can say it is a general purpose programming language. It has ready-made packages and libraries for machine learning. You need not to write the code from the scratch. You can just use them directly in the code. So for some example, which we talk about matplotlib, numpy, scipy, scikit-learn. So this is a very, you might have heard also about this scikit-learn. So this allows you to write very good machine learning and the deep learning models you can very easily implement using this library. Similarly, TensorFlow, it has an excellent support for deep learning models. Apart from this, it also interactive data analysis and modeling using IPython notebooks also. So we have a very interesting feature called the concepts of notebooks. These are coming whenever you will go for writing any programming language or a program you're going to write. So the concept of notebook is coming up. So in Python also, we have that concepts of notebook where you can write your code and at the same time you can test it also. Instead, rather than writing the code fully, you just write one line of code, execute it, test whether the results are okay or not, or analyze those results, then move further, improve your code, and you can, and this, since I am getting the output line by line also. So you can write a very exhaustive code also while testing each and every step you are able to test it also. And obviously, it is an industry standard language for artificial intelligence and machine learning. It has already established itself as an industry standard language. So some of the libraries which are very extensively used for machine learning in Python, they include NumPy and Matplotlib, the very basic one. You should basically have a good knowledge, or we can say a good experience on these two these two libraries, NumPy and Matplotlib. If you are having a good a hands-on kind of thing on experience of this NumPy and Matplotlib, you will be able to write a good machine learning model in using the Python programming language. So these are at the very base level. Apart from that, we have the pandas. This is again one a very we can say customized library which is based upon this NumPy and Matplotlib. Together, you have the models, and there are certain libraries which have been customized within the pandas. Okay, so this is one library that can be used. Similarly, MXNet is another very useful machine learning library which is available in Python. Theanos, Keras, TensorFlow. This I told you for the for your deep learning models, Spark, MLlib, scikit-learn, you will be having a good experience or good learning curve for this scikit-learn. Whenever you will Google it, Python for machine learning, then this will be the first search you will be getting, scikit-learn. So many researchers or many people, they are using this particular library for developing the machine learning codes in Python. Similarly, we have the PyTorch also, a little bit extensive, and it is not that much very easy to learn into that part. But although there are certain libraries are available over the internet through which will allow you to get into the deep into this PyTorch concepts as well. Now, if we talk about the TensorFlow, so these are some of the deep learning libraries. If we talk about, it is useful in handling the deep neural networks. Natural language processing can be performed with the TensorFlow, partial differential equations. So these also play a very important role during building a deep learning model. So these are very easily implemented in this TensorFlow. You need not to write the code from the scratch. Modules are available there. You just use your model and dot PDE or the partial differential equation, and you will get those results into it. Only you need to change the parameters over there. Similarly, it has abstraction capabilities, image, text, and speech recognition, and it also allows effortless collaboration of ideas and the code. You have certain ideas, libraries are already there. You write the code, and you will go get all those results. So it is offered by the Google. It is a fast, flexible, and scalable open source library. If we talk about the Keras, it is basically meant for the neural layers, and it has the activation and the cost functions available with it. So you will be learning more about these neural networks also. So there we have the concepts of activation and the cost functions also. In the coming lectures, you will be having more onto these neural networks also. But here, these methods are directly available in Keras. So it is objective, batch normalization you can perform on top of it, and dropouts you can do, pooling also that can be performed. These are some of the key terms which you will be facing in the deep while developing a deep learning model. It also supports for convolutional and recurrent neural network. These are again to CNN or RNN. So these modules or these methods approach are also very much supported for the Keras. So if you are going to build a RNN network or a CNN network or CN network, so you can directly use this Keras model there. You need not to write much of code onto it. So basically, it is a high-level API for the TensorFlow. Similarly, for the one more library we have that is known as the PyTorch. So it basically for the tensor computing with the ability via graphical processing unit. So if you have an hardware with a GPU unit, if you have a GPU over there in your hardware, then it can harness the capabilities of GPU also for developing these deep learning models. It is easy to learn there, use and integrate with the Python ecosystem. Again, tensors, it will also get integrated easily with the tensors. Optimizers are there, neural networks you can develop on top of it. Automatic gradient calculations, they are also performed using this PyTorch application. This one basically, scikit-learn. So these are some of the very machine learning. Now, earlier we were seeing about the deep learning models. So we have learned that TensorFlow, Keras, PyTorch, these are the deep learning models, deep learning libraries available in the Python. Similarly, if we talk about the machine learning libraries, so under machine learning libraries, we have a very good library that is called the scikit-learn. Okay. Now, this scikit-learn has the modules like classification, regression can be performed, clustering can be done, dimensional reductions you can perform on top of it, model selection, and pre-processing. These are some of the tasks which are customarily performed in a machine learning workflow. So these all are available under this scikit-learn. I will not go into the detail of classification, regression, and the clustering. This will be covered later on in the coming lectures. Basically. Similarly, for the data preparation, so before you put your data into a machine learning model, you need to prepare the data for pre-processing of the data. So that pre-processing of the data, some of the tasks which are available, which are performed during the pre-processing, they include data reshaping, pivoting, merging and joining of the data set, handling the missing data or the data alignment, various indexing options such as hierarchical access indexing, fancy indexing, or data filtration options. These all are readily available in this library called Pandas. So it makes use of some of the data frames. Basically, data frame is a two-dimensional data structure. So through this, you can accomplish all these tasks. The pre-processing of the task can be performed using the Pandas libraries. One more library we have, that is called Spark ML It also allows regression, the same thing which were available with the scikit-learn. Regression, clustering, optimization, dimension reduction, classification, basic statistics, feature extraction. And it also allows you to easy scaling of your computation. So you can easily scale up your computation using the Spark MLib library. Theanos, it is again a machine learning library. It supports GPU here. Now we have an additional feature over here. If you have your hardware, your computer is having a GPU unit over there, so that can be utilized using the Theanos. Strong integration support with the NumPy, and it also allows you to it also has the ability to create custom C code for your mathematical operation. Basically, it is a very robust library for carrying out scientific calculations on a larger scale. MaxNet, if you talk MXNet, it is also a very, I have come up to the deep learning library, highly scalable, and it supports quick model training. It can be used to train and deploy the deep neural networks. It also allows you excellent portability and scalability. So you can port your data to any other platforms, and similarly your data can be scalable. It can be improved upon with additional input data sets, and additional features or parameters can be inbuilt into it. Now here, this MXNet, basically this Amazon's AWS, they are using MXNet as its choice for deep learning models. So it is being used extensively for the Amazon's cloud service that is called AWS. Now this we have already again. If we talk about the data preparation library, so this NumPy and Matplotlib, earlier also I told to you. So these also allow you. These are at the base level, and this Pandas was basically a customized form of both these libraries. So they are inbuilt into it. So if you can do for the shape manipulation, sorting and selecting capabilities, discrete Fourier transformation can be performed, basic linear algebra, statistical operation, we will be seeing some examples of it, random simulations, support for n-dimensional arrays. So these can be performed using these particular libraries. Now, once we are known for deep learning libraries, machine learning libraries, and some data preparation libraries that are available in Python, let us go further to the environment where we can code these libraries, or we can code a Python program. So there is one Jupyter notebook in Anaconda. So Anaconda is a very we can say a framework, a platform which has the capability, which has the features, a component called Jupyter Notebook. So if you can see it here, whenever you install Anaconda in your computer, so it gives you the interface to write your workflows or implement your workflows in using different kinds of tools and technologies. You can say this Anaconda, it allows you to write R code as well as, and Orange, this is some programming environment over there that can be written over there. Similarly, but our area of interest will be the Jupyter Notebook. So you can write a complete code on top of a Jupyter Notebook. So this allows you to write your code over there. So once you are invoke this Anaconda, then it will give you an icon for a Jupyter Notebook. Just click it on and you will get it. Another option is Google Colab. So if you have a Gmail account, so or a Google account, over there also you can write your Python code. So Google also provides you an excellent environment wherein you can uh, write a Python code, and that code can be used for any purpose, like for machine learning or any other general purpose applications. So let us take now one example: linear regression using least square estimation. This is our task, and we want to perform it using a Python code. I will just go through the slides only. If you see here, linear regression. This term regression is used when you try to find the relationship between the variables. You have n number of variables and you want to find out a relationship between those variables, how they are varying. Example, if you can take, you have a yield, crop yield is there, and this crop yield is dependent upon certain parameters. It can be like wind speed or health of the health of the crops at the time of during the cropping time. That can be calculated using various techniques. One of the technique is we can get it from NDVI, that is a normalized difference vegetative index, that can be calculated from the satellite images. So apart from that, what is the duration of the sunshine, what is the solar insolation, we can say, wind speed, solar insolation, health of the crop, and how much fertilizer is done over there. So all these parameters, they are dependent, they will directly affect the yield of the crop. So we have different kinds of parameters, or these are called the variables. How these variables are related to each other. How much is the wind speed affecting the yield? How much is your solar insolation affecting the yield? How much is the health of the crop is affecting the yield? So all these parameters, they are built using a regression technique. So in machine learning and in statistical modeling, that relationship is used to predict the outcome of the future event. So once your relationship is built, then you can easily predict the future outcomes from that relationship. So now, although there are different kinds of regression, there is one very simple regression, that is called linear regression. It uses the relationship between the data points to draw a straight line through all of them. So first, whenever you are plotting the data set, a straight line can be, if they have a straight line kind of relationship between them, then we build a linear model on top of, or a linear regression model on top of those data sets, like this. So this line can be used to predict the future value. We have plotted the values like this. On the x-axis, some x variables, and on the y, we have the y variable. Now we are plotting these values over here. These are the data points which are known to us. And we can see that it is following a very linear trend. So this line can be predicted. We can have an equation for this line. So that line will allow us to predict these values for future values or data points. Or in similar lines, we have another algorithm we call as least square estimation. A very common problem in the experimental work is to obtain a mathematical relationship like this: y equal to fx between two variables x and y by fitting a curve to the points in the plane corresponding to various experimentally determined values, say x and y. Suppose I have a large number of values in these pairs, x1, y1, x2, y2, xn and yn. Now we want to fit a curve, a mathematical relationship between these data points. How to do that one? So for that, we have one method called least square estimation. So on the basis of theory, or simply by the pattern of the point, one can decide on general form of the curve y equal to fx to be fitted. Which model I should fit over there? You just plot them as a scatter plot you draw, and some of the possibilities you will get from by observing the data set, it can follow a straight line. So for a straight line, your model will be something like this. y equal to a plus b x. Now this a and b you need to determine. X and y are known to you, and a and b you have to follow. X and y, from where we will get it? From this known data points. You can fit them over there, and you just estimate the value of a and b. Your model will be developed. Similarly, it can also have a quadratic polynomial. So it has the form like this: y equal to a plus bx plus cx square. And similarly, we have a cubic polynomial as well. So it has the degree. It has the polynomial has a degree of 3. So this way we can build it. Suppose, let us take one example. We want to fit a straight line y equal to a plus bx to an experimentally determined data point. These are some of the data points. Now we want to fit a straight line into it. How to do that one? So what you do, you take the first data point, put it over there, y equal to a plus bx1. Take the second point, make second equation, take the third point, and similarly for all those endpoints, you just put them in this equation form. This a and b will be unknown. X1 and y1, x2 and y2 values are the known observation which you have taken from the field. Now, if these points are on a straight line, then the following equalities hold for these points. If you see it here, now we can write these equations in the form of matrix like this: y1, y2, and y1. I will just tell you how to code all these. Just all these tasks can be done with a single line in Python. We will see how to do that one basically. So I was just trying to explain you that it has a sound mathematical background and there are various steps into it. Now these all steps are directly can be used by a single method available in the Python from certain libraries. So if you see a y1, y2 and y1, these values are known to you. You can form one matrix over here. And similarly for the x1, what you have to do, you put the first column as 1, 1, 1 and the second column as the variable number, that is the independent variable. This can be put it over here, and a and b are the two unknown values, a and b. These are same for all. Okay. Now, or more compactly, we can also write y equal to mv. Okay, y is, these are the variable, and m is your slope. We can say this component over there, and v are the two unknown variables. Now, if we are trying to fit a least square curve into it, this is the method derived from the mathematics. You can see it here. Was our unknown variables, and we have m of transpose of m multiplied by m, then inverse, then transpose of m, and then y. This is your y values here. Okay, these are the y values. So you can see how to do that one. Suppose we have the following 4 observations: 1, 2, 3, and 4. We can write them. This is x, y, xy, xy, xy. So in the y we have 1, 3, 4, and 4. 1, 3, 4, and 4. Similarly for m, we will have the independent variable. First column will be your m 1, 1, 1. Second column will be your 0, 1, 3, and 2. 0, 1, 2, and 3. Okay. So the solution will be v equal to transpose of m. You find the transpose of m, multiply it by again by m, find out the inverse of the matrix, again multiply them by transpose of m, and you will get these two values 1.5 and 1. So your best fitting line is y equal to 1.5 plus x. Now this, how to do this entire process in Python, finding out the transpose, multiplying the matrix, and then performing the inverse of the matrix. This itself is a huge task if you try to do it manually. But in Python, if you see here, just by writing this line, I can able to get these 2 points. Simply numpy import star x equal to matrix, your x variable 0, 1, 2, and 3. This matrix is again coming from the numpy. Directly I am forming one matrix over here. And this is, you can say 1, you can say 0, 1, 2, and 3. Similarly, y matrix we have 1, 3, 4, and 4. You can see here 1, 3, 4, and 4. First is 0, 1, 2, 3. 0, 1, 2, 3. 4 elements are, 4 columns are there. 4 rows are there. First row, second row, third row, fourth row. And in Y also we have the 4 rows. And then matrix we will form. How to form the matrix? First column is 1, second column is the Y value. So if you can see it here, 1, 0, 1, 1, 1, 2, and 1, 3. 1, 1, 1, and 1. This is the first row, first column, first column and second row, 1. This 1 we are putting over here. And this, the second value will be the independent variable. This is 0, 1, 2, and 3. That we are putting into the matrix we are forming. And then directly we are applying that formula. M dot T. T means transpose. This is coming from the numpy. Multiplied by M, then dot I. That is, will calculate the inverse of the matrix. Then multiply M, again transpose of T into Y. This is your Y value. And you will get directly print V. These are the values 1.5 and 1. So you can see 1.5 and the coefficient of A is 1.5 and B is 1. So that is a 1. Now if you plot it, you will get this line over here. You can see it here. We have found, now we are using another library called PyLab. So you can have here plot X comma Y. X and Y, these are the two values. You have plotted them with the red color and circle. So X and Y, these are plotted. This is your X variable and these are your Y variable. If you can see it here, X is 0 and Y is 1. So you see here, X is 0, Y is 1. Another is 1 and 3. So you have 1X and Y is 3. So these dots are plotted. Now using that equation, now once it is plotted, now we want to plot this line. So in order to plot this line, you will try to calculate a huge number of independent variables, that is Y values. So I am creating some X values. So I am creating some X values by this method called arrange, or we can say it will calculate the value from -1 to 5. -1, 0, 1, 2, 3, 4, 5. Certain values it will create, some random value. Then what we can do, this Y equal to 1.5 plus X. This was the equation we have found it over here, 1.5 and 1. So 1.5 into X, plus X. So it will calculate this Y value also now. These are the new X values and these are the new Y values. If you plot them by blue color and dash, you will get this particular line over here. So you can see here, so we are able to get the result simply by some few lines of code. Now suppose you want the data to be a quadratic equation, like suppose you have the 5 data points, 1, 2, 3, 4, 5, and you want to put some higher order polynomials like A1t, A2t square. This kind of equation we want to fit. So that also becomes very easy here. If you see, you plot, you denote these values in a matrix form like this. S1 and T, second, third, fourth, and fifth equation for all the 5 points. Okay, same equation. Now it can be written in the matrix form like this. So here if you see, Y will be your all these S1, S2, S3 and S4. Your M, that matrix will be, first column will be only 1. Second column will be A1 and this, T1, T2, T3, T4, T5, these values. These are the first order variables or the first order independent variable. And then we have the second order independent variable. This is T1 square, T2 square, T3 square, T4 square, and T5 square. These values are there. Okay. Now, if you put it over here, if you see numpy, X matrix, and similarly we have the Y matrix, and if you say M equal to 1 and 5 comma 3, it will create 5 rows and 3 columns with all filled with ones. Directly I am writing here a blank matrix. First column has ones and there will be 5 rows and 3 columns. Then what I am doing it here, M colon first. So you replace all the rows, this column means all the rows and first column with the value X. These values will be coming over there. Similarly, all the rows and second column you multiply X and X. X square will come there because we have this value called X square. This is X and this is X square. So we are having that X square. Now you put that formula there, M dot T into M dot I, M dot transpose and Y, and you will get these 3 variables. So your equation will be minus, it will be like S equal to minus 0.40.35 T and 16 point T square. So if you can see it here, 16 point T square, this is the first value, A, B and C. These 3 variables, A, B and C are put it over here. Now if you are plotting them, you can see I am getting a curvilinear arc of it. These points were following a curvilinear pattern, we can say, and we have fitted this equation. So this equation is perfectly fitting it. So your model is a very best fit model over here. From that equation you have found it out. Okay, and we have verified it also using this Python. So why I was telling to you all these things is it becomes so simple to code complex mathematical problem in a Python programming language. The learning curve is also very simple in this term. All the term like plot, it is a simple, from that name itself we can understand that it is going to plot something. If you can say plot x comma y, this is the x variable, this is a y variable, and then what we want, r dot arc o, red color, r for red color and o for the circles. So that's what it has plotted it over here. Similarly b and dash, so blue color and dash it has put it. So the learning curve basically is a very simpler one in case of this Python programming language. You need not to define the variable name. Directly assign it x equal to a range, y equal to some other variable. Now, multiple regression. The mathematical trick of finding a matrix form of the equations can be extended to this multiple dimensions also. In that case, we call it as multiple regression. Here we are having only 2 or 3 variables. Now the same trick, the same equation, it can be extended for multiple variables. In that case, we call it as a multiple regression. In the complete code, you can see over here. I will share with you also this code. Import numpy as np, and then from sklearn dot linear model, we are using it over here. Import linear regression. Suppose I want to do a linear regression over there. So x equal to np array 1, 1, 1, 2, 2, 2, and 2 and 3. These are your data points. And we can directly do y equal to np dot, this method we are using from sklearn, dot x np dot array 1, 2 plus 3 plus np dot random and some values, random values I am generating. So I will get this. This is your basic small model. This model, if you want to fit it over there, and REG regression, you can create the regression model over there, like linear regression, reg fit. This is your x values, and this is your y, which we have created over here, and you can find out the statistics based upon it, like reg dot score, reg dot coefficient, reg dot intercepts, and you can predict it also, this value np dot array 3, 5. For this value you want to predict something. So this is one small code that is used for the linear regression. So if you take one example here, I have one code with me. I have the crop yield, some data I have created, crop yield estimation. Okay, so if you can see it here, for this this data set is for the state of Uttar Pradesh. Okay, so if you see here, we have created this data from various sources. Like this is for all the districts of Uttar Pradesh. First is Agra, and that data is from 2001 to 2014. And what are the data? What is the mean temperature in the district of Agra? What is the relative humidity? This data we can get it from the satellite data products as well. Okay, then mean pressure, mean wind speed, weather information, mean wind direction, mean rainfall, surface insolation, surface net solar insolation, evapotranspiration, how much was there, NDVI, and what is the crop, name of the crop, and this area in 2001, 2002, this all in hectares. This we have got from data.gov.in. There is one website by the government of India. From there we can get this yield also. They are always publishing over there this yield value. So from there we are getting it, and these are the parameters we have used for it. So you can see this data, a sample of this data set I can share with you also. So that now you can see it here. It is for all the districts. First is Agra, Aligarh, Allahabad, and for 2001 to 2014 up to this. Auria district 2001 to 2014. Similarly, Azamgarh. For all the districts, we have compiled the data. Now, this data set, some of the data is missing also here. If you can see here, this data set. So we have deliberately, what we have done, there are certain data sets which are missing. Like here, for this particular city, I don't have the data for me. This thing, Sant Ravidas Nagar. So a huge data has been created, but we were not able to get this particular variable for it. What is this variable? You can just check. This variable name is net solar insolation. We were not able to derive for this Sant Ravidas district, Sant Kabir Nagar. We were not able to get it. Similarly, for this value also we were not able to get for it. So these are some of the missing data set. So we need to process these missing data set as well. So if you can see it here, a small code that we have written. We suppose I want to now. If you see here in the data set itself, you have certain variables are there. Okay, go back here. So these are all your variables. You can see from the district side. If you see, this is the first variable, year, and then we have mean temperature, relative humidity, pressure. These are all your x1, x2, x3 variables are there. Okay, these are your variables. X, Y, Z, many variables are there. The temperature T is there, R relative humidity, P pressure, W wind speed, WS. These are your variables, and you have an associated yield also with it, 3.05 hectare. This is the area in which this crop was sown, and we got the yield of 3.05 hectare, 3.2 hectare in tons per hectare basically. So we have these are the input independent variables, and this is our dependent variable yield. Now what we want, this is up to 2014. So from this data we can create a model, and then this model we can test also from this data set itself. Once the data is tested, then we can find out for the yield for future dates also. For 2000, suppose let us say 2000, it is up to 2014 only. Now we want the estimate for 2015 or 2016, let us say. So from that model, this can be estimated. From that machine learning model, that can be easily estimated. Now, if you see the code for it, if you have it here, import pandas from scikit-learn, import linear model. We want to fit a linear model into it. So we have created one data variable, pandas.read Excel. I am reading that Excel file. Simple, very simple methods are there. This is a pandas, then dot read Excel. You take the data set dot XLS, it will put all the data set in your df variable. Now df equal to df drop any, that no values, you drop those variables. Any method you can apply and that can be dropped. Similarly, df equal to df drop columns. I don't want the columns like district, year, crop, production and in tons. These variables are not required. So simply df dot drop, it will drop those values variables from there, from the from this df variable. Now y equal to, now our y variable, y is our yield basically. So we are saying y equal to df dot pop. You take those values of yield tons per hectare. This was there in our variable. If you can see here, this was yield tons per hectare. The same variable field name has gone over there, and it comes it over like this, yield tons per hectare. This is the name of the field. So all those values will go into y variable. Similarly, x equal to df dot values, all the values it needs. Okay. Now y equal to numpy. You create, you import these values into a numpy array. Okay. Earlier there may be some string variable, because whenever we are exporting the data from CSV to your into your programming data variable, that comes in the form of a string that you need to convert into a integer form, some numpy form. So y equal to y dot to numpy. I have imported it like this, and then we have reshaped those values -1, 1, and then you can see here linear model dot linear regression. Simply I am writing this is, I am preparing the data in these 4 lines. Okay, and here I am just fitting the linear model into it. Once the linear model is created over here, then you can fit these x and y values into it. Y model underscore yield dot fit x comma y, and then you can predict it also using these 2 lines of code itself. So that becomes a simple machine learning model. You need not to write a very complex programming tools over here. You can just see it over here. what we have done, we have only done a scripting of the steps over here. All the steps are written one by one, and you are able to develop your own machine learning model as well. Similarly, if you can see here, data splitting is also a very important task over there. What you do, you divide your data into two parts. First, you half of the data, let us say 60% of the data, you can use for the training purpose. And from once the training is done, from that trained data, you create the model. Once the model is created, the remaining 40% data, you can now put it into the model and test it. Outputs already you have, the yields. So whatever values will be coming, based upon that, you can find out the accuracy of your model. Suppose 80% of the data, raw data, or the test data is matching with the data which is coming out from the model, then we can say the model predicts your accuracy of the model is around 80%. So similarly, this is basically required for the, so once you better the accuracy of your model, better becomes the prediction for unknown data sets also. For the data which you don't have for that one. So this was again, if you see it here, clustering. So you search 2-3 lines only. The clustering is one very popular algorithm which is used in the machine learning. So we can directly use it like sklearn.cluster, import k-means, then import numpy as np, and you can, this is some sample data set. It can come from Excel or from image, from anywhere it can come up. And then when we do the k-means directly I can use how many clusters you want, what is the random state, and then fit x. So, and then k-means dot labels, it will give the labels to them and predict for these two values. And k-means cluster centers can also be calculated. So 2-3 lines only. So you need not to write the full code. Simply you have to call those methods, and you should be aware what are those parameters which are being used for this k-mean. For that, you should have a thorough knowledge basically. What are the parameters that are required for k-mean? Okay, so like number of clusters, very basic parameter. Similarly, for some advanced machine learning algorithm, you should know what are the parameters which are getting into that particular algorithm. Okay, so that you need to, you have to be aware for that. So for that only, in the future classes, whenever these methods will be taught to you, just keep in mind, you try to understand what are the parameters that are being used for that particular algorithm, what are the input parameters, and what kind of outputs we can derive from that method. So that thing you should be you should learn while going through the classes of these algorithms basically. So that will be covered in the in your future classes also. Ki what do you mean by the cluster, how it is doing it, what is the basic algorithm behind the cluster, that will be taught to you in the coming classes basically. So this is one small example. So with this I end up over here, and I hope I have given you some insight ki how this Python programming language, how simple it is to code your machine learning approaches for your workflow deployment, or for for getting the outputs from something from your applications basically. Okay, so